So, dear students, today we will discuss the polarization in a polar molecule. Okay, polar molecule already have the poles, that is positive charge and the negative charge separation. In polar molecule, the center of positive charge is not coincide with center of negative charge. Okay, due to the factor, if suppose we have the example HCl, chlorine is the more electronegative element, it pulls the electron towards himself through the bonds, therefore it is having delta minus charge and it is having the delta plus. The pulling element or atom has the delta minus charge, it pulls the electron through the bonds and which is having get the partial delta minus charge, and the electrons pulled from that particular atom having the delta positive charge. Okay, therefore in polar molecule there is a pole is present. Okay, therefore other way we can say that the center of positive charge and the center of negative charge are the maximum apart from each other. Okay, therefore in polar molecules, without applying the electric field, okay, the molecules are present in randomly. Okay, that it is having the permanent dipole moment, that is positive negative charges, it is having the charges, and these molecules are randomly places anywhere okay without applying the electric field. Okay, therefore the net dipole moment for the polar molecule without applying the electric field will also zero, because these molecules are randomly placed. Okay, the dipoles, okay, molecular dipoles, the molecules dipoles are randomly placed. Okay, any direction it is placed. Okay, therefore the dipoles cancels to each other, therefore the dipole moments will be, the value of dipole moment will be 0 for polar molecule also, though it is having the positive and negative charges are separated, but due to thermal agitation the molecules are randomly placed and its dipoles is also randomly placed, therefore its net dipole moment is 0. But when we apply the electric field, at one side there is positive and the negative electric field we show from positive to the negative direction, and our expectation is molecule should be orient like that. Okay, like that our expectation. Okay, applying the X electric field, that is the positive end attract towards the negative end and the negative end attract towards the positive end. Okay, but due to thermal energy or the temperature which is having that system, the molecules is not aligned in a perfect direction. Okay, that molecules is aligned the 180 degree Celsius with the field, but it takes the intermediate direction. Intermediate direction means the direction in between the applied electric field and okay, the direction, it takes the mean direction, that is the direction in between applied electric field and its original direction, in between the applied electric field and its original direction. Okay, our expectation was it should be remain as a 180 degree to the electric field, but it takes the position in between its original position and the applied field direction. Okay, applied field is like that, the direction of applied field is the 180 degree and its original was the like that, but it takes its the position in between the applied electric field and its original position. Okay. There are two polarization possible. First polarization is induced polarization. This induced polarization is also present in non-polar molecules. The distortion of the charges takes place in this system also. Okay, therefore it induces the more distortion in molecule due to electric field, and this distortion in the charges gives the induced polarization. Okay, therefore induced polarization is also present in non-polar molecules, and it also present in a polar molecule. Okay, first that induced polarization is present in both molecules, polar molecules as well as the non-polar molecules. Okay, therefore due to the distortion of the charges, this induced polarization is produced. Okay, induced polarization in non-polar molecules we have given like that: 4/3 pi n alpha, and pi n is the constant, n is Avogadro's number, pi is a constant, and alpha is deformability or polarizability for molecule. Okay, first change is produced in molecule is distortion of charges takes place. Due to distortion of charges, induced polarization takes place, and that Pi is the induced polarization is given by the formula 4/3 pi n alpha. In both the molecules for the induced polarization, same formula is there. Okay, but when you apply the electric field, when you apply the electric field apply a torque or force to this molecule, to this dipole, to orient along its electric field. But due to the thermal agitation means it is having some temperature, and due to this temperature molecules vibrating. Okay, such situation only happen when permanent dipole moment is present in a molecule. Permanent dipole moment is present only polar molecule. Therefore, such orientation in between the electric field and its original position is produced in polar molecule only, because it is having the permanent dipole moment. Okay, therefore applied electric field apply a torque to this molecule or force these molecules to orient that dipole moment towards the electric field. But due to this thermal agitation, your molecules is the vibrating. Okay, due to this vibration, molecules not takes the such position. Due to this thermal agitation, molecule takes the position in between its original position and the applied electric field. Higher, if temperature is higher, this vibration will be higher, and the position is not changes. It's not like that position is observed. More and more temperature is you given to the system or the molecule, its polarizability is the decreases. Okay, polarizability is the, in this case, is the more, because it is aligned in the electric field. But for this polarization, it's the less polarization is there, because it's not aligned in the perfectly in the electric field. Though it is having the negative charge at the positive direction, this direction, this is the this direction, this positive will be this direction align. Okay, there is a aligning of positive in the negative direction, but it's not perfectly aligned. It takes the position in between the applied electric field and the its original position. Okay, therefore when you applied the electric field to the polar molecule, it is oriented like that. It's not oriented like that. Because why? Because the thermal agitation. Thermal agitation means what? Molecules or these dipoles vibrates due to the thermal energy. Okay, therefore this is happen only which is having the permanent dipole moment. This polarization, okay, due to the polarization appear due to orientation is called as the P naught. PO or P naught. O stand for the orientation, P is the polarization. Okay, orientation polarization is produced due to the orientation of these dipoles of the molecule. Okay, therefore in a polar molecule, the molar polarization will be equal to induced polarization and the orientation polarization. Okay, in non-polar molecule, molar polarization or the total polarization is equal to induced polarization, but P orientation is not present in a non-polar molecule, because orientation polarization is only present in polar molecule which is having the permanent dipole moment. Okay, therefore we have discussed the induced polarization is present in both molecules, that is non-polar molecules and polar molecules, but orientation polarization is not present in non-polar molecule. Therefore for non-polar molecule we can give the equation as the total polarization or molar polarization we have given like that: D minus 1, that is dielectric constant, D plus 2 molar mass upon density is equal to 4 by 3, is equal to P induced, and P orientation is not present for the non-polar molecule. Therefore molar polarization or total polarization for non-polar molecule is only the induced polarization. In non-polar molecules orientation polarization is not possible. Orientation polarization is present only in the molecule which is having the permanent dipole moment. Okay, therefore, for polar molecule, total polarization or molar polarization will be equal to P induced plus P orientation. Induced polarization, we have the formula is same for the non-polar also and the polar molecule. For induced polarization, the formula is 4/3 pi n alpha, and the relation for the non-polar molecule is given by the Mossotti and the Clausius scientist, and this is equal to, it's related to the dielectric constant d minus 1 d plus 2 mass upon density. Okay, we have already discussed what is meaning of d. Okay, therefore in this lecture we will not discuss the what is meaning of dielectric constant. Okay, now we have find out the equations for the polar molecule. Okay, polar molecule, the molar polarization or total polarization will be equal to polarization, induced polarization and the orientation polarization. Induced polarization is given by the equation 4/3 pi n alpha. Okay, this is the polarizability of the molecule or deformability. Okay, therefore in this case, for the orientation polarization, alpha orientation, okay, alpha is not is equal to the mu square upon 3 kt. Okay, therefore orientation polarizability or the deformability is depends upon the your permanent dipole moments, okay, directly proportional to the permanent dipole moment and inversely proportional to the temperature. Okay, therefore temperature increases, our molar polarization is the decreases, because as the temperature increases, the thermal agitation increases and its position is also not will be in the direction of the applied electric field. Okay, therefore orientation polarization given by 4/3 pi n, that is alpha mu square upon 3 kt. Okay, therefore molar polarization for the polar molecule will be given by this equation. Okay, all these terms are the constant, and in this equation all these terms are the constant except the temperature. Okay, therefore molar polarization in a polar molecule, it depends upon the temperature. Okay, because all these factors are the constant. Okay, therefore total polarization, okay, total polarization will be equal to, if it is constant, if you given we name the A. For this, if this is a total, that's 4/3 pi n mu square upon 3 kt. K is our it is a constant, K is the constant. Okay, that is the Boltz, that K is called as the Boltzmann constant, mu is the dipole moment, n is the Avogadro number, pi is the constant. Okay, therefore if this total term we taken A, this 4/3 we taken B, and T is the, okay, like that we have obtained the equation. Okay, therefore the equation will be we can shown like that, if Pt is equal to B upon T plus A. In this equation our A quantity will be 4/3 pi n alpha, and B is equal to 4/3 pi n mu square upon 3k, B quantity and the A quantity. Okay, therefore when you compare this equation with equation of line, you will get y is equal to mx plus c. therefore this is the y quantity, and this b is the constant, therefore b is the your slope m, and t x is the 1 upon t, therefore y is equal to b, the total polarization, m is equal to b, and our intercept c is equal to a is our intercept. Okay, therefore when we draw a graph, okay, our slope is the positive, therefore okay, in this case b is the positive, therefore when you draw this, okay, for CH4 it is a straight if you increases or decreases temperature, or CCl4 it is also straight. These are the non-polar molecules. Okay, therefore non-polar molecules, okay, that graph, non-polar molecule, it's straight, no effect of the temperature on the non-polar molecule, its total polarization remains constant. Okay, then CHCl3, okay, its polarization is the increases as 1 upon t goes on increasing. Okay, and then again is our HCl is there, it's again increases because it is a polar molecule. Polar molecules, the polarization, total polarization is increases, and non-polar molecule it remains as a constant. Okay, therefore for this equation is for the polar molecules according to this that slope is the constant, therefore that particular line will be moves towards the upside. Okay, therefore like that way we have defined the molar polarization in our polar molecules. Thank you very much.